Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, Palindrome linked list. So what the problem says is that we get a head of a singly linked list, and we want to return true if it is a palindrome. A palindrome basically means the left portion is the same as the right portion. Yeah, pretty much. So for example, 1, 2, 2, 1 is a palindrome because on each side, if you traverse from the left going right and from the right going left, the values are equal. So 1 equal to 1, 2 equal to 2. So that's what palindrome means. Here it's not, because 1 is different than 2, right? If you take like 2, 3, 3, 2, that's a palindrome as well, right? So how can we solve this? So the easy thing to do is actually pretty simple, which is just convert the linked list to a list of numbers, and then traverse from the basically check every number I against n minus I up until n divided by 2, right? Basically that will allow you to check the first half is equal to the second half. And for the left half, you would go left to right. The right half, it's enumerated from right to left, right? So that's a pretty simple solution. However, it's not the one we are looking for, but let's just show you what it would look like quickly. So it would be something like this, where we can just get the list from the linked list, right? So we just traverse the linked list, and each time we append the value. And then once we get the list, we just traverse it. We go all the way to the n divided by 2 index, and each time we check at index I, and on the other side at index n minus I minus 1, and that will give us both sides. So we'll be traversing from left to right here and from right to left here. And as soon as we find something that is not equal, we return false, right? And if all of them are equal, we return true. So that's like the solution here, with the easiest solution to do. However, this is oven time, right? Here we go through the linked list one element at a time, so oven, and we do also oven iterations here. However, we are using oven space to hold this list, and in the problem we are asked to do it in oven time and ov1 space, so no extra space. So let's take a look at how we can do that solution. Okay, so let's see now how we can do a solution that is of1 space instead. So the way to think about it is we want to do it while traversing the linked list. So intuitively, what do we want? We want the first half to be equal to the second half reversed, right? So we want 1, 2. So the second half is 1, 2 like this, but if we go in the normal order, left to right, 2, 1, right? So we want these two parts to be equal to each other. So we can either check 1, 2 against this one reversed, so the right half reversed. So 2, 1 reversed. In Python, that's like this. Or we could do the reverse, basically check against the 2, 1 against 2, 1 without reversing this one, right? And so what we can do is check that the reverse of the left side, reverse of the left portion is equal to the right portion, okay? And right portion traversing from right to left like this, which means basically if we take the linked list and reverse the first half, so that would be 2, 1, then we can start from here and from here. So this is, let's say, pointer 1, pointer 2, and each time we check when we go to the next one, right? And if we traverse all of them, they are all equal, we return true, and if we find anything that is not equal, we return false, right? So let's take a look at like a better example here. So let's take a bigger one that is like 3, 4, and then 3, 2, 1. So this one should be a palindrome, right? So what we can do is find the middle first, right? So we find the middle node, so that would be here, and then we can reverse everything up to the middle, right? So this is step 1. Step 2, reverse first part until the middle. So that would be basically means here doing 2, not 2, sorry, 3 is the first one, 2, 1, and then we have the rest 4, 3, 2, 1. So we leave the middle as is. So with this we can just start a pointer from here, right? Let's call it for the left side, and for the right half we started at mid or mid.next, at mid.next, right? And then we compare, are these equal? Yes, we advance left to here, we advance right to here. Are these equal? Yes, we advance here and we advance here. And then once we are both at this at null, we can check either at null or we can check at mid here, right? We can check either one to note that we exit. And that's pretty much it. So, and then the last part, check left equal to right side, pretty much. Okay. And so here, let's say we had 5. Then when we are checking 2 different than 5, we can return false because this is not a palindrome, clearly, right? Now, one problem happens. What if, so in this case, it was 3, 6, so the length was 7, so it was an odd length. What if it's an even length, right? So something like 2, 1, 1, 2, right? So in that case, we can't do like here where 4 we just skipped it, right? So we know that the first for the left side we have to start here, but where should the right side start? Here it started at right, started at mid.next, right? For when odd, right? But here when it's odd, when it's even, we want right to start here. So for this to be a palindrome, yeah. Let me. So this is the first linked list, but let's reverse, which is the second step. So that would be 1, 2, 1, 2. Right. So where do we want the right to start here? We want the right to start here and left to start here. So you can see when the length is even, we actually the mid would be. We want the mid to start here. To start in the right to start in the mid. So when even, we want right to be equal to mid. Okay. And so that's like the main high-level idea. First, find the middle node, and find whether the length is odd or even. While doing that, and then reverse the first part until first part basically means from the beginning to the mid, and then check if the left side is equal to the right side. All the values on the left are equal to the values on the right. Okay. With right definition being this and left being at the head. Okay. Now the second part of this is how do we find the mid and how do we reverse? So reversing is easy. That's just reversing a linked list. But here it's we stop when we reach the mid node. But the first portion, how do we find the middle node? Well, so find mid node. Well, that's where we use the fast, slow trick basically. So let's say we have 1 to 2 to 1 to 2. So we can use slow that starts here and fast both start here, but fast, the fast pointer needs to move twice and the slow pointer moves just once, right? Each time. So first we move slow once and then we move F twice, right? So, and then we move this here. Then what happens? Then we move fast twice, and so fast now is at the nil pointer, is none, and slow is here. Right, and so we stop when, so basically stop when F is none, right, or nil. And so S would be our mid. Remember, this is exactly what the mid would be here, okay? And so basically just do this slow fast traversal, and then slow would be the mid pointer. So we saw that it works for an even length. Let's just make sure it works for an odd length linked list. So we'll start slow and fast here, and then we would move slow here, fast here, right? And then we'll do a second iteration, which is move slow here, fast here. And so here we stop. We can stop when fast is none. So here stop when F is none, or fast.next is none. So here we stop, and this is our mid, right? This is the right mid pointer. Okay, so pretty much with this, and this would be our loop for when we stop. So with this we can find the middle node. Now how do you tell if it's odd or even? Well, you can see here in this solution it's odd, and here it's even. So when it's even, f fast pointer is at none, and when it's odd, the fast.next is at none, right? So basically what this would mean is that we can tell that it's odd if f is not none, right? Because it's pointing at the last node. And basically it's even if it's pointing at none, right? If it's outside of the linked list. Okay, so that's the idea of how do we find odd, and how do we find the mid node. And then now we come to the reverse part, which is the second step of our algorithm. So reverse. Okay, so how do we do this step? I think the easiest way to reverse here would be using recursion. So I'll just do that. So how do we reverse? Well, we know that with reversing, let's say we want to reverse 1, 2, 3. All it means is that instead of pointing to the next pointer here, we want to point to the previous, right? So we know that we are with a function where we want to reverse. I'll write the pseudocode sort of in Python here. So we have, let's say, the current node, and we have the previous node that starts out as nil. So what we know that we want the current node next to be pointing to the previous. Okay, but we need to hold reference to this one 3, right? Because we want at the end to have this, right? So we need 3.next to point to 2. So we need to keep a reference of what is current.next, right? Let me just move this down a little bit. So we keep track of this, but why we do that? Because we want to recurse. So let me say we want to do reverse on this node here, the current.next, because we want to reverse it next. So current.next. What should be the prev of the previous value of current.next, right? Because we will end up making this 3 here point to 2. That's what we want. Okay, we want 3 to point to 2, and we want 2 to point to 1. And so what do we want? We want the previous of 3 to be 2, so that we can point to it. And so that's why we pass previous here, right? Okay, so just to reiterate, what are we doing? So 2, 3 here, and maybe let's say we have 4 or something like that. So let's say we are here. So what do we want? We want to remove this and make it point like that. So for the node 2, when we are calling reverse on it, we will give it, so the node 2, we will give it as prev node 1, the one from the previous iteration, right? Because we want 2.next to be equal to 1, this iteration here. And what do we want the next iteration to see? Well, we want it to have 3, right? We want the next iteration to be called on reverse for node 3. What should be the previous for node 3? It should be 2, which is the current node, right? This is current. So the prev would be node 2. And we'll do that each step on the traversal, right? I hope this is clear. I found it more clear with the recursive function for reversing. And now the only thing remaining is the base case. So when are we done? Well, we are done when we reach the end here. So if not current, or when the current, in our case here, we want to stop when we reach the middle. So that's just for our case, not for reversing any linked list. For while we are different, so if we are equal to the mid node, we want to stop, right? So if current equal to mid node, we want to stop. So that's just for our use case here. And at that point, what do we want to return? We want to return the priv, which will hold the last element, which is our new head, right? So we want to return that. Yeah, so that's pretty much for the reverse function. Okay, so now we know how to reverse, we know how to do find the middle node, and we know how to check that the left side is equal to the right. So that's the overall overview. Now let's write this and make sure it passes test cases. Okay, so let's implement the solution that we just saw. So first, we need to find the middle node and whether it's odd, whether length is odd, right? And so let's just define a function, call it mid, and we'll define it. That gets like the head of the linked list. Then we need reverse until mid, right? Outside until mid. So let's call it reverse until. And we need to pass with the current node, the previous node, and the mid node, right? To be able to know when to stop. So the previous, which starts out as none. Okay, we'll define that one also. And then what we need after that is to check left is equal to right side. Okay, and basically we need to assign left pointer and right pointer correctly, right? Based on odd or even length. So that's what we did in the overview. And then at the end, we can just do the check. And if we find that it's different, we return false. Okay. So let's first write finding the mid. So we said that we will use 2 pointers, slow and fast, that both start out at the head. And then while fast is not none, which is just fast, and fast.next is not none. Because when even, we would have fast is none. When odd, we would have fast.next is none, right? And so we check for both. And now slow should advance to slow.next, and fast should advance to fast.next. And this should work fine because we are making sure this is not none, so this would never fail. And now we want to return, once we are done, we want to return the mid, which is the slow pointer, and we want to return whether it's odd or not. So odd is when fast is not none, right? Which basically means fast.next is none. So we can also check fast.next is none instead. But yeah, it's easier to do it like this. So we return odd. So we return a pair of the mid node and whether the length is odd or not. Length is odd, let's call it. Okay. So that's the first thing there. Now let's do our reverse function. So what we need to do is do the base case, which is current is none, which means not current, or we reach the mid node. Middle node, we want to stop. We want to reverse only up until the mid node. Middle node, right? So here we want to return the head of the new reversed portion. So that's why we return previous. And then we do what we did for the reversal. So we save the next, and then we point the next for the current to the previous, and then we reverse on the next one with the previous being the current one, and then we need to pass node again, the mid node again. Okay, so that's the reverse portion. Now we need to assign left and right. So now I'm just going to handle one case here just to save us from edge cases. So if the head is null, or it's just one element, or we have just one element linked list, then we know it's a palindrome by default. So here we can return true. And now we can proceed with our function call. So first we get the mid node and whether the length is odd by calling find mid on the head. Okay, and then we get the left pointer, which should be the reversed left half, right? So we wanted to point to the head of the left side after it's reversed. So that's why we call a reverse until, and we take whatever it returns. and we passed with the head as the start, the middle node, and the prev starts out as none, so we don't need to worry about it. Okay. And then for the right pointer, we said it's just the mid node if it's even, and the mid.next if it's odd. That's what we saw in the overview. So it's mid.next if the length is odd. Otherwise, it's mid. Just go back a little bit to the overview if this is not clear yet. And now we can do our check, right? So we assigned the pointers. Now we can do our check. So basically, while both pointers are still, actually we just need to check right pointer, because when the right pointer exits, we know we should exit, right? Because left at that point would be just before the middle, right? So we can just do that. And if at any point we find that the values differ, that means we don't have a palindrome. So if the value is different at any point, okay, maybe let's just call it left and right. I don't think we need this pointer thing. So if at any point we find that the values is differed, we return false. Otherwise, we just advance. So left.next, and remember, left is traversing from left to right for the left portion, right is traversing from left to right for the right portion. And so we do right. Right starts out at either mid or mid.next and goes all the way to the end. Left starts out from the head and goes all the way just before the mid, right? And so we advance right pointer as well, right.next. And now at the end we want to return something, so we return. When do we know we have a palindrome? Well, basically when right is when right is none, right? That means so we return not right, or right equal to none, because that would mean we stopped only and we didn't find anything here, and that's pretty much it. So let's just, so I'll just write this in a Python way, so not right instead. And now we can run this. So this is mid node, right, and this here is mid node. Okay, let's submit. Okay, so that passes test cases. Yeah, so again, just the general overview. We find the mid, and we find whether the length is odd or even. We reverse the left side up until the mid node. We go from each left and right pointer. We keep checking if the values are equal. If ever we find them not equal, we return false because it's not a palindrome. So that's pretty much it. The gist of it is that, let's say you have even like, if you have it as a list like this, right? The only thing you need to do is just reverse. So 2, 1, 3, 2, 1, and now you could just do a pointer here, do a pointer here, and check 2 is equal to 2. We are good. We advance both, and then 1 equal to 1. Good. We advance both. We advance both again, and now we are at the end. And so we are at the end because right is equal to none, and we didn't find any values that are different, so we return true. And that's pretty much the main idea here. Now in terms of time complexity, this here is O(n) time, finding the middle, and of1 space, because we are just using 2 pointers and traversing. Reverse O(n) time as well, and here, and we are now using extra space, and here we are also doing, we can also do this like in a while loop if you kind of think the reverse would use a stack and you don't want to use that. You could do this also iteratively. And then here, this is also O(n), and we are not using like extra space. We are using just pointers. So overall, we are doing it in the in what is asked here in the follow-up. Yeah, so I think that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.